Hey guys, I thought I'd go ahead and help you out and talk through some of the problems that were on tonight's worksheet before tomorrow's quiz so you have a chance to hear them after you've done your work, right? So for numbers 4 and 5, we're trying to find the sum. Remember, that's what sigma means, is the sum, even if I don't write the word sum in the problem. And I gave you a hint. They may not be arithmetic or geometric. Remember, for arithmetic, you're looking for that linear pattern, and geometric, you're looking for something exponential. Now, I know you see exponents in numbers 4 and 5, but to be exponential, your exponent must be that variable. So number 4 is actually a quadratic function, and number 5 is cubic. So we don't have any special formulas for these. We're going to have to just write out all the terms and add them all up manually. Okay, so number 4, we're going to find the first term in the sequence by plugging in the bottom number. Oops, I did that again. The bottom number for j. So if I plug in 0 for j, I get my first term is 1. Plugging in 1, 1 squared plus 1 is 2. 2 squared plus 1 is 5. 3 squared plus 1 is 10. And then the last number I'm going to plug in is 4. So 4 squared plus 1 makes 17. And then we add those together to get our sum. So 3 plus 5 is 8, plus 10 is 18, and 17 should make 35 as your sum. Number 5, same idea, except now I've given you 10 terms that we need to actually find. And I'm going to cheat here a little bit. Because there are 10 terms, what I'm going to do is go to my calculator, and I'm going to enter that equation. So 2x to the third, because if I go to a table of values, I can see what happens as I plug in the numbers from 1 to 10. So when I plug in 1, I get the value of 2. And then the next one is 16, and 54, and 128. Let's see, plugging in 5 gives me 250. I need to go all the way up to 10. So 432, 686 is 1k equals 7, or x equals 7. Then we have 8, 9, 10. So 1,024, 1,458, and 2,000. I'm going to let you go ahead and add those up together because I don't want to type them in. Okay, so anyway, if you don't have a special type of sequence like arithmetic or geometric, you really just have to write them all out and add them all up. Okay, now next section we're writing in sigma notation. And remember, that just means we're going to go for the sigma. You're going to write your expression here after the sigma, and then above and below put in the values that you would plug in to get the first and last values in the sequence. Okay, so let's see, in looking at number 6, I'm seeing that the top is just 1, and the bottom are all multiples of 2. So if this is my first term and my second term and my third term, it looks like each bottom is really just 2 times that term number. So I'm going to say 2n represents the bottom. And we can check. If n is 4, I get 8. So I'm guessing this would be my 10th term. 2 times 10 is 20. So in sigma notation, I have 1 over 2n. I'm going to plug in 1 to create the first fraction. And I'm going to plug in 10 to create the last fraction. And there we have our sigma notation. Okay. For number 7, let's see. It looks like we've got each term has a value of 2 being multiplied, and then the number that's being squared just is increasing. So it looks to me like we're doing 2 times something squared, 2n squared. So in sigma notation, I have 2 times n squared. The first value of n that I need to create that first term would be 1. And then the last value that I need to create the last term would be 9. So there's my sigma notation. Number 8 and number 9, similar. You can't see 9 right now. Similar. 8, I'm telling you it's arithmetic, which means we're adding. We've got the first term. We've got our difference, or our slope. We're finding the first 5. So I'm starting at 3 and I'm adding 4 each time. So 3, 7, 11, 15, 19, and I've got my first 5 terms.